Hello. No modern physicist will be able to explain you what exactly is meant by the wavelength of a photon. Don't believe me? Ask them. There is only one explanation they can give you. Wavelength of a photon is some property that causes diffraction and interference. But it's observed only after we launch millions of photons with the same wavelength. So, what is wavelength of a single photon? In one of my previous videos I've assumed that each elementary particle is actually a discrete machine that consists of discrete pieces. E equals reduced Planck's constant multiplied by W. W according to that assumption is not frequency but the amount of discrete pieces in particle. Reduced Planck's constant according to that assumption is not quantum of action, but quantum of energy instead. Quantum of energy that causes discreteness of action. Each discrete piece of particle stores one of 6 possible directions in space: up, down, left, right, forward, back, and moves all the particle in corresponding direction of space with constant momentary speed in infinite loop. Link to that video is in the upper right corner now. Please watch it if you want to understand the assumption better. Let's imagine that particle consists of one discrete piece. In this case that discrete piece navigates the whole particle all the time. Let's imagine that particle consists of 2 discrete pieces. In this case each discrete piece navigates the whole particle one after another and both of them navigate the particle half of the time. Let's imagine that particle consists of 3 discrete pieces. In this case each discrete piece navigates the whole particle 1/3 of the time, etc. Let's assume that elementary particle has momentary speed a meters per second, therefore each second it passes the same absolute distance a. So we can say that for particle consisting of 3 discrete pieces each discrete piece makes its contribution to absolute movement, which equals to 1/3 of the distance a within 1 second. For particle consisting of w discrete pieces the contribution of each discrete piece within 1 second will be a divided by w. What does it mean for the particle? It means that if any discrete piece is replaced with some other discrete piece pointing to some other direction, the contribution to absolute movement that original discrete piece was making will not be there anymore. Instead, particle absolute movement gets contribution from a discrete piece with another direction and that updates the absolute movement of a particle. In another video I've assumed that elementary particles interaction happens through exchange of the discrete pieces and have shown how that leads to Heisenberg uncertainty principle. Link to that video is in the upper right corner now. So every interaction changes state of the particle and therefore the direction of its movement. As a result, after 1 second of movement particle finds itself in another location. The set of all possible locations that particle with specific energy can find itself after 1 second of movement together with corresponding movement directions are the so-called wave per my assumption. And that's actually the only thing we ever observe in experiment. We never observe any wave. We always observe only photons that move in specific direction. Please note that after each interaction the total amount of discrete pieces in particle can change and the contribution of each discrete piece therefore changes too. But if we speak about particles with huge amount of discrete pieces, that gives almost no effect. As example we can review photon that represents color between green and blue. We say that its wavelength is 500 nanometers. If my assumptions are correct, it would contain 3.77 multiplied by 10 to the power of 15 discrete pieces. We would need a lot of interactions to change its wavelength much. Now let's show this wave. Let's assume that we have a set of small particles, which consist of discrete pieces with directions right or down. Let's assume that those particles move through a field. That field makes them change state of one of its discrete pieces from right to down or from down to right with predefined probability. And that probability changes as reverse squares law depending on the distance from particles to sources of field. We can see that the further particles are from sources of field the less often they change direction of their movement. As a result, some directions of movement appear to be more probable than the others. If we change the amount of discrete pieces in particles, Number of possible direction changes, and we literally see how wavelength becomes shorter and shorter as particles get more and more energy. Just as it should be. Please note that it's not interference or diffraction. Those have different mechanisms and are to be described separately. It's obvious that different photons have different speeds in these examples. Per my assumption, constant speed of light is a result of the way matter interaction works. For simplicity, those algorithms were not applied and will have to be explained later, in separate videos. Let's demonstrate what exactly it means for photon. Let's get back to photon with wavelength 500 nanometers. Wavelength is calculated according to formula. Lambda equals c divided by f, where f, frequency. Angular frequency is calculated according to formula. W equals 2 pi multiplied by f. If we substitute f, we get W equals 2 pi multiplied by c divided by lambda. Earlier I've explained that if my assumptions are correct, then the real speed of light should appear to be at least square root of 3 times faster than c. Link to that video is in the upper right corner now. Absolute speed A equals square root of 3 multiplied by c. Contribution of each discrete piece of photon to its absolute movement in this case equals A divided by W equals square root of 3 multiplied by c divided by 2 pi c divided by lambda equals lambda multiplied by square root of 3 divided by 2 pi. If we substitute lambda equals 500 nanometers, we get contribution about 138 nanometers. So if I'm right and did not miss anything, each discrete piece of 500 nanometers photon contributes only about 138 nanometers to photon's absolute movement per second. Any interactions update absolute movement of photon 138 nanometers per second per interaction. Please note that I might have done some mistakes here. Future will show. But it's unknown territory, I just can't be always right. I can only hope to be right sometimes. So what is waving in photon? If I'm right, the answer would be, nothing is waving. It's just the probability for any photon of specific energy to get or not to get from one specific location in space to another specific location in space. Photon can move only in specific directions, therefore probability is either 1 or 0. But photon moves through space and interacts with other particles, and each interaction updates its movement direction. If there are enough interactions with other particles, the original predetermined direction structure disappears. In this example, particle state is updated with constant probability, and you can see how predetermined structures disappear with time. I believe it's called decoherence in quantum physics. Also, according to my assumptions, the observer effect has the same nature. In statistics it would probably be called normalization. Here is another way to demonstrate it. Imagine that we have normally distributed starting points for normally distributed processes. As time passes they merge together and we get a wave of probabilities, or wave behavior as physicists would say. Sooner or later all of that merges into one normal distribution. Decoherence happens and we get particle behavior as physicists would say. As a result, we've shown the possible connection between the wave properties of photon, its speed, energy and reduced Planck's constant. Also using this approach, de Broglie wavelength, Compton wavelength, redshift, blueshift can be explained. I will explain those in my next videos. And of course at some moment I will have to demonstrate how all of that is connected with interference, complex numbers, exponent, circular motion, Bell's inequalities and the theory of everything. And get another 30 views. Haha. Please note that I have a separate video about diffraction and interference. Link to that video is in the upper right corner now. That video explains the general idea of what and why happens in interference and shows example of algorithm that produces similar effect. The proposed explanation does not include any non-locality, no photon passing through two slits, no photon being aware if it's watched or not, etc. No any miracles expected. The exact explanation of what happens there will be available after we get the algorithm of matter. But the problem is that algorithm of matter would be the theory of everything. It's not here yet. Anyway, the mentioned video includes predictions, and those predictions can be checked in experiment. I hope at least some of you enjoy the possibility that the mysterious quantum mechanics could be explained someday. I don't say that I'm right, but even if there is something right in what I describe, it's already huge. At least I think so. It's much more than the popular shut up and calculate approach. Thank you for your attention.